Hello all, and thank you for listening to another video of Mr. Laxton talking through these Algebra II Section 8.1a notes. Alright, so we're getting into Chapter 8, and we're looking at exponential functions here, exponential growth and decay. We're looking at log functions, different logarithmic things, the number e, different things like that. So, going to be honest with you, Chapter 8 is kind of the longest section of the year, so stick with us here. Make sure you don't fall behind, and let's get into it. Alright, so in Chapter 8, we're going to do a lot of different graphing. Alright, and this first one, and I have my such a question here, is how do I graph exponential growth functions today? And we're going to really look at a lot of these graphs, and we're going to describe a lot of these graphs with this domain and range. Alright, and the way that I like to remember domain and range is Dix and Roy. Yes, laugh all you want, we're mature enough, Dix and Roy. D-I-X and R-O-Y. That's how I remember what domain and range are. Domain, D obviously stands for domain, is the input values, and it is the X values. Alright, so that is the domain. And the range is really just the opposite. R obviously is the range. The O is the output values. Yes, you guessed it right. And the Y is the Y values. Alright, so that's going to help us when we look at here to describe these. What's the domain and range? That's going to help us to see, hey, does my X approach something? Does my Y approach something? What's my output? What's my input? Kind of things like that. Alright, so exponential growth functions are in this form. F of x equals a b to the x. So if you want to highlight that, that'd be a good idea. That's kind of the base that we have here, y equals a b to the x. And then we're going to talk about kind of the second part of the notes here. How do those things move around, like up, down, left, and right? Alright, so a couple different things here. Your a is the y-intercept. So a lot of times that might be 1. It might be 1 times b to the x or whatever it might be. The domain of this function is x equals that fancy all reals. Alright, so this fancy r means all real numbers. Alright, so there we go, all real numbers. Alright, the range of this function, if a is greater than 0, then y is greater than 0, and if a is less than 0, then y is less than 0. Okay, so that kind of tells, is this graph going to swoop up or is it going to swoop down for exponential decay or growth? Alright, and behavior, so as x goes to positive infinity, f of x goes to positive infinity. And as x goes to negative infinity, so that's looking at the left side of this graph goes down and gets really, really close to 0. Alright, never goes past. Alright, and that's kind of the thing that we're going to look at with a lot of these things is what number do they get really, really close to? And again, that number that it gets really, really close to is called that asymptote. It's a line that it gets really close to but never goes past. Alright, so those are kind of some of the key things that we're looking at here in this chapter. Alright, so example number 1, it says graph y equals 2 to the x. Alright, and just like we've done a lot of things, let's just go through and we're going to plug in some x values, -2, -1, 0, 1, and 2, to see, hey, what does this guy actually do kind of in that middle part of the graph? Alright, so let's kind of start with 0. What is 2 to the 0 power? Anything to the 0 power, remember, is 1. And hopefully that starts to make sense with some stuff up here. It's because at my a here, even though I kind of don't really have one, it's 1 times 2 to the x. So my y-intercept should be at 1 right there. Alright, so now let's keep on going here. 2 to the first power is 2. 2 to the second power is obviously 4. Now here's where they get a little tougher. What's 2 to the -1 power? Remember how that goes to the bottom, so this is going to be 1 over 2 to the first power, which is 1/2. And then 2 to the -2 power, you might be able to guess, since this is 4, this is going to be 1/4. Alright, so here we go. Do your best here. It doesn't have to be perfect. So -2 1/4 is like right there. -1 1/2 is right there. As we keep on rolling here, we got 0 1 and we got 1 2 and we have 2 4. So this graph looks like this. It starts and gets really, really close to that 0 on the left side, and then it grows exponentially on the right side. Okay, so now let's quickly talk about what is my domain and my range. My domain for these is always going to be x equals all real numbers, all right, because there's no x value that these guys get really, really close to. It keeps on going on and on forever in this direction and in this direction here. All right, but now my range. My range is those y values. Remember, that's Roy. See how it gets really, really close to this line right here? All of our parent functions are going to get really, really close to 0. So this is y is greater than 0. It gets really, really close to that 0, but never goes past. So that's why my range is y is greater than 0. All right, so as we roll on here, it says exponential functions can also be shifted left and right and up and down in this equation right here. So this is going to be a huge equation. We're going to see a bunch. Again, that h is the one that's up top with my x, and that moves it left and right. All right, and maybe want to write a little opposite note for yourself. It's always the opposite of what it looks like. So your h is the opposite of what it looks like, and your k moves it up and down. And your k isn't the opposite of what it looks like. Notice how that's a plus there. So it just stays whatever your k is. All right, so that's what we're going to do. So that's really what we're going to look, is that we're going to sketch the graph of ab to the x first. So we're going to graph the parent function first, and then we're going to move it up, down, left, and right with whatever we need to. All right, so let's take a look at this. As I start graphing this, I kind of always like to do this. I always like to square in my parent function. So your parent function goes just past that x and then stops. All right, and we're going to bring in that -2 and that 1 a little bit later. So here's my parent function. I get y equals -2 times 3 to the x. So now let's just go through, plug in -2, -1, 0, 1, and 2, and see what we got. So these kind of got that one little extra step here. So I'm just going to go like this, f of 0. I always kind of like to start with 0. It's usually the easiest one. So it's -2 times 3 to the 0 power. And I know that 3 to the 0 power is 1, so this is going to be -2 times 1, which is -2. So this is going to be -2. Awesome. As we go on here, f of 0, we already did f of 0, so now we have f of 1, -2 times 3 to the first power. 3 to the first power is 3, so I get -2 times 3, which is -6. And my last positive one, f of 2, is -2 times 3 to the second, which is -2 times 9, and that is -18. All right, so this is what, -18? Oh, -18. All right, and as you go on through here, these guys actually do a lot of flipping around. So if I plug in f of -1, so I'm just going to kind of do that over here since I ran out of room. F of -1 is going to be what? -2 times 3 to the -1 power, which is going to be -2 times 1/3, which is -2/3. And this over here is going to be -2 ninths. All right, -2 ninths. Again, you can just plug those in your calculator and get a decimal if you're not familiar with those, and that's okay. All right, so now I go through and graph these guys. This guy, I got -2 and -2 ninths somewhere in there. -1, -2/3, 0, -2. 1, -6 is right there. So I always kind of like to draw this in here. This is my parent function. All right, so here we go. That guy keeps on going on and on forever. This is my parent function, but now I still have to move. So this is my parent. I still have to move this guy up, down, left, and right. So I notice here that my h is going to be 2. And my k is going to be 1. Remember how your h is the opposite of what it looks like. Your k is what it looks like. So this means I move right 2, because my h moves it horizontally, so that's left and right. And my k moves it vertically. That's just how I like to remember it, vertically. And this moves it up 1. All right. So now every single point I need to move right 2 and up 1. All right, so here we go. As I move these guys, I have to go right 2 and up 1. So I kind of just guesstimate here. Right 2, 1, 2, up 1 is going to be right in there. Right 2, up 1 is going to be somewhere in there. Right 2, up 1, that's going to be a nice point. And right 2, up 1 from there. Okay, so now notice that, hey, this is where you got to be really precise, and this is where I'm going to make sure I check to make sure you are precise. What number does this get really, really close to now? Okay, all of these points over here in my red got really, really close to 0. But I move every single point right 2 and up 1. So now all the points get really, really close to 1. All right, so that's where they should be really precise. They go through there, and now this is my final. All right, awesome. So now my domain always is that fancy looking R for these absolute growth and, wow, exponential growth and decay. And now my range is this Y is now less than 1. See how it gets really, really close to that line, Y equals 1, but it doesn't go past. So that's why it's less than that for this one. Okay, so we'll do a lot of examples of those graphing, but the main thing is here, make sure you graph the parent function. All right, so graph the parent function, then move it up, down, left, and right. And this one might look, you might say to yourself, hey, that kind of looks like decay. It's going down, right? But that's actually still exponential growth, and we're going to look at exponential decay in the next section here to see, hey, how is that different? All right, so this one is still exponential growth, even though it's got that negative in front of it, so it makes it go down. All right, awesome. So that is exponential growth graphing, and we'll talk a little bit about exponential growth equations in the next part of this section. So again, thank you for listening, and we will see y'all later.